After a thorough group discussion, we have chosen Masjid Al-Mursyidin located within campus Sultan Azlan Shah at Universiti Pendidikan Sultan Idris, Tanjung Malim Perak, as the focus of our assignment. For this project, we are analysing a specific section of the mosque exterior wall, which stand out due to its distinct geometric pattern and architecture feature. This wall features a combination of rectangle, square and triangle, especially visible in the window and panel design. By studying this element, we aim to connect the mosque architecture detail with the geometric concept we have learned in class. Through this analysis, we have to get a deeper appreciation of how mathematics is applied in real-world architecture.
Masjid Al-Mursyidin, a mosque on the campus of Kampus Sultan Azlan Shah Universiti Pendidikan Sultan Idris in Tanjung Malim, Perak, Malaysia, that has been chosen as the assignment's location. It's near academic and college block. It serves as a central place for prayer for students, lecturers, staff, and the community around the campus. The mosque architecture, especially its outside design, are the combination of modern construction with the traditional Islamic geometric element, making it look functional and attractive.
Next, for the usage and function of the structure, I will go to the main building first. As you can see, Masjid Al-Mursyidin is located near to the college and the academic buildings. This will ease the Muslim staff and students to perform their prayers during the academic session. Other than that, Masjid Al-Mursyidin is also a place for the Muslim guys to do their Friday prayers every week. Other than that, there are various activities that will be held in the Masjid Al-Mursyidin, such as iftar, ceramah, and community programs to strengthen the bonds between the community and students. Moving on to the first structure that our group has studied, which is the triangular windows. It is used to maximize the entry of light, maintain the brightness within the mosque during the daylight. And the second structure is the square ventilation window. It is used to maintain proper air circulation, reduce heat, and maintain humidity within the buildings. Both of these structures is used to prevent rainwater from entering the building.
Size in diagrams. As we can see from the photo provided, the length of the wall is 12 meters and the width of the wall is 1 meter.
We have chosen mosque exterior wall. This wall has different shapes that make it interesting. Most of the shapes are rectangle and square. You can see this shape in the window and the wall panel. Above the window, there are triangle pattern made with colored glass. These triangles are the same on both sides, which make the wall look balanced. When you put the rectangle, square and triangle together, they create a nice and balanced design. This shows how simple shape can make the mosque look beautiful and special. For the geometric shape of the wall, specifically focusing on the triangle incorporated into its design. The wall prominently features two triangles. The first is a smaller triangle with a base measuring 100 cm and a height of 50 cm. The second is a larger triangle with a base of 200 cm and a height of 100 cm. As we know, triangles are closed, two-dimensional shape characterized by three sides and three angles. An important property of triangle is that the sum of their interior angle always equal to 180 degrees. To calculate the area of a triangle, we use the formula 1/2 times the base multiplied by the height. These triangles are not just a simple shape, they contribute significantly to the wall overall aesthetic and structural design. By incorporating this basic geometry form, the wall gains dynamic visual interest and architectural strength. In summary, the use of triangle in the wall design beautifully illustrates how fundamental geometric shape can be, enhance both the appearance and functionality of architectural structure.
Moving on to the geometrical concept. In this section, we will study about the measurement, perimeter, and area of each shape that our group has studied. So for the first shape is the smaller triangle within the bigger triangular windows. For the measurement of this triangle, we get that the base is 100 cm, the height is 50 cm, and the length is 70.7 cm. For the perimeter, we use the formula of perimeter equal to base plus 2 sides. And when we insert the value, we get the perimeter of this triangle is 241.4 cm. For the area of this triangle, we use the formula of area equal to half multiplied by base multiplied by height. So when we insert the values, we get the area of this triangle is 2,500 cm squared. For the second shape is the bigger triangular windows. We we get the measurement of the base is 200 cm, the height is 100 cm, and the length is 141.4 cm. We use the same formula of perimeter and area as before, and the perimeter that we get for this triangular windows is 482.8 cm, and for the area is 10,000 cm square. When we study both of these shapes, we get that this smaller triangle is congruent to the bigger triangle because it satisfies AH and SSS property of congruence triangle, which is side angle side and side 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 property. For the third shape, it is the right angle triangle ventilation window. For the measurement of this triangle, we get that the base is 100 cm and the length is also 100 cm. Using this value, we calculate the hypotenuse of this triangle, which is 141.4 cm. For the perimeter of this triangle, we use the formula of perimeter equal to base plus length plus hypotenuse, and we get the value of perimeter is 341.4 cm. For the area of this triangle, we use the formula half multiplied by base multiplied by length, and the area of this triangle we get is 5,000 cm square. When we study this shape, our group get that the left side of the right angle triangle is congruent to the right side of the right angle triangle because it satisfies the HL hypotenuse length property of congruence triangle. For the last shape is the square ventilation window. For the measurement of this shape, we get that each side of this square measured 100 cm. For the perimeter of this square, we use the formula of perimeter equal to 4 times sides, and we get the value of the perimeter is 400 cm. And for the area of this square, we use the formula of area equal to side multiplied by side, and the area of this square is 10,000 cm square. In square, all sides are congruent. A square is also a quadrilateral. A quadrilateral is a polygon with 4 sides. Lastly, since all of these patterns are in the form of triangles and square, then the parameters that can be measured are the area and perimeter.
Transformation in motif empathy. In geometry, transformation is the process that changes the position, size, or orientation of a two-dimensional shape. Transformation play a crucial role in geometry as they are used to study and analyze the relationship between figures and understand how they can be manipulated while preserving certain properties. There are several types of transformation with its own characteristics. The four main types of transformation as I'm going to describe. First, translation. Translation involves sliding a figure in a specific direction to another in the same direction and distance without changing the original shape or orientation. The movement can be done in any direction. Next, rotation. Rotation is the turn of a figure around a fixed point that is known as the center of rotation. It can be done at a certain angle, whether in a clockwise or anti-clockwise direction. Next, reflection. Reflection is a transformation that creates a mirror image of a figure over a specific line known as the line of reflection. Each point of the figure is flipped to the opposite side of the line at an equal distance. Last one, dilation. Dilation is the size of a figure, either enlarging or shrinking the figure while maintaining its shape from a certain point using a specific scale. Transformation in motif. The concept of transformation does exist in the motif on the top wall of the main entrance of Masjid Al-Mursyidin. I will explain you that. First, translation. In the photo provided, we can see that there is proof that there is a transition from the green triangle to the blue triangle. When a shape undergoes a translation, it slides in the straight line without turning or flipping. The blue triangle is at the bottom right of the picture, and the green triangle is at the bottom left. The green triangle is able to reach the precise location of the blue triangle by moving horizontally along the large triangle's base. Throughout the movement, they maintain the same side shape and outward orientation. This demonstrates that there is only a direct horizontal shift in position and no rotation or reflection. Next, reflection. The transformation between triangle red and triangle brown is an example of reflection. Triangle red reflects across a horizontal line to become triangle brown on the other side. The horizontal line acts like a mirror placed between them. Both triangles are the same in size, shape, and direction. They point straight upward and downward, making them perfect mirror image. The only change is their position is that one is above and the other one is below. Since their orientation flip while the structure stays the same, this movement can be classified as a reflection. Next, rotation. The image clearly proves that a 90-degree rotation of a triangle green around point C to triangle red. Initially, the green triangle ABC is positioned horizontally. When rotated 90 degrees clockwise about point C, it aligns vertically, forming the red triangle. The triangle's size and shape stay the same in this transformation, but its position changes. The right angle, which is 90 degrees at point C, is the key to understand this change. Angles and lengths don't change because rotation is a rigid motion. This shows how this figure can be moved by a 90-degree rotation without changing its size. Point C is the pivot and the other points move along is a circular arc. Last one, dilation. The image shows the geometric dilation, which is the small green triangle is enlarged to form the bigger triangle. The point O is the center of dilation. Each vertex of the small green triangle moves outward from O along the dashed lines, creating the corresponding vertices on the larger green triangle. From the photo, we can see that the distance from O to A prime, B prime, and C prime are proportionally greater than those from O to A, B, and C by the same scale factor. The triangle remains the same, preserving angle ratio and size ratio, but the larger green triangle is a scale-up version. Reflection on the right angle triangle model. Two triangles with a 90-degree angle that is a right triangle are visible in the picture. One is on the left and the other one is on the right across the vertical line. Across the center vertical line, the right angle triangle on the right is like a mirror copy of the one is on the left. The triangle with a right angle turns upside down, like when you look in the mirror, yet the size and form stay the same. Only the orientation has changed while others remain the same. Translation on the square root. The picture displays two blue squares flanking a window. The left square is a shift version that moves horizontally to the right, aligning with the location on the right square. This shows a conversion process where the dimension, form, and position of the square stay the same. Only its location moves along a straight path as shown by the arrow at the bottom right of the picture.
Hello everyone, right now we are entering the transformations in patterns of the wall in Masjid Al-Mursyidin. So look at the first transformation of the pattern. The first transformation, as we can see the diagram, is translation of the pattern of the wall. Let's look at the example. The triangle A is sliding to the right to create the same size and the same shape of image A prime through the horizontal line. And it is the same concept that applies from the triangle A prime through the triangle A prime prime through the horizontal line. And it is the same concept that applies to the other triangles and the squares that shown in the diagram. Therefore, we can conclude that the translation of the pattern of the wall is exists as it's sliding to the right through the horizontal line. Let us move to the second transformation. Okay everyone, right now we are entering the second transformation of the pattern of the wall, that is the reflection. The reflection is the process of flipping either through horizontal line or the vertical line to create an image of the same size, the same shape, and the same direction of the object. Let us look at the triangle A. The triangle A is undergo the reflection process through the vertical line in order to create an image of triangle A prime. It is the same concept that applies for the triangle A prime in order to create an image of triangle A prime prime. So this process is also applies to other triangles such as the triangle B, the triangle C, and the triangle D. So in the conclusion, we can conclude that the reflection process exists in the pattern of the wall. So right now we're entering the summary of this assignment, and I will handle this floor to my members. Thank you.
For the summary, we focus on a section, the mosque exterior wall, which measures 12 meters in length and 1 meters in wide, as display a variety of geometric shapes and symmetrical patterns. In the motif, we observe translation in triangles and square sliding horizontally reflection through mirror-like fifth rotation where triangles turns 90 degrees and dilation as a small triangles, enlarged proportionally. This same transformation also appear in the overall wall pattern where triangles and square repeat through translation and reflection while maintaining their size and patterns. This is how geometry adds balance, symmetry, and aesthetic value to the mosque architectural design. These patterns reflect concepts like symmetry, congruence, and transformation, which are fundamental in mathematics. The mosque serves a central prayer space for students, staff, and the community around the mosque, and its design beautifully combines traditional Islamic geometry with modern construction.
Hello everyone, we are back here to make a real conclusion based on this assignment. So based on this assignment, we can conclude that the assignment is conducted for us in order to observe all objects everywhere around Usi. And it can also let us learn how to appreciate all the geometrical shapes and the geometrical concepts everywhere around us from time to time. And last but not least, this assignment also helps us to conclude that most of the knowledge that we learn in this class is always related to the daily life, such as the designing of the structure of the building, crafting the object, designing the structure of the vehicle, and so on. So guys, this is the end of our presentation of SMG3013, that is geometry. Thank you for your listening, thank you for lending your ears. I hope you guys learned from this assignment and I hope you guys like it. See you guys, bye bye.